Hello students, welcome to my YouTube channel. So today we will be doing with exercise 1.1 questions 1.1 question number 2, that is, so that any positive odd integer is of the form 6q plus 1 or 6q plus 3 or 6q plus 5 where q is some positive integer. So we will start this mm, solution 2 by first we will start let us start with taking a. Okay, start with taking a. Let us start with taking a. Since any number can be written as a equals to bq plus r form, no, for example, suppose it is a is a 5. Okay, so we will write like this, no, 2 into 2s are 4 plus 1, r is your remainder and this is your quotient, no, quotient, and this is your divisor. This is a dividend and this is a divisor, no, divisor, dividend, and this is a remainder. Okay, so what the question has asked is this. So what the question have asked is that, so that any positive odd integer, like for example, any positive odd integer means 1, 3, 5, no, these are odd integer but it is positive, no, can be written in the form of 6q plus 1, 6q plus or 6q plus 3 or 6q plus 5. Now the question has asked like this, where q is your quotient, okay, or q is your some integers, q belongs to some integers. Okay, so we will start by taking a. Okay, so where what is a? Where a is a positive odd integer, positive odd integer. So we apply the division algorithm. Okay, we apply the division algorithm, division algorithm with algorithm with a and b as 6 we will take. Okay, since remainder should be in between, 6 lesser than 6 or equal to or lesser than equal to or greater than 0, no. Okay, remainder should be in this form, so the possible remainder, it can be the possible remainder are 0, 1, 2, 3, 4 and 5. Okay, that is a can be, so that is a can be, since see here, let us start with taking a. No, we have a where a is a positive odd integer, so what can a be? A be 1. So this a can be 1, no, a can be 6q or 6q plus 1 or 6q plus 2 or 6q plus 3 or 6q plus 4 or 6q plus 5, where what is q? Where q is quotient. However, but what it has given already, like we have assumed, no, a is a positive odd integer, but this 4, 2, 4 are not, the q, 2, 4 are not positive odd integer, no. So we, however, since a is odd, and a cannot be 6q or 6q plus 2 or 6q plus 4. Why? Because since they are divisible by 2, divisible by 2. The positive odd integers cannot be divisible by 2, no, that's why this cannot be 6q plus 2, 6q plus 4 cannot be, they are divisible by 2, so this cannot be odd. Okay, so what we will write is like, therefore what we have remaining, therefore any odd integer is of the form. See, if we take out this 6q plus 2 and 6q plus 4, what we have as remaining, we have 6q plus 1, or 6q plus 3, or 6q plus 5, no. So what is asked in question, just see here, so that any positive odd integer is of the form 6q plus 1, 6q plus 2, 6q plus 3, or 6q plus 5, where q is some. See what we got, therefore any positive odd integer, any odd integer is of the form this, so hence proved.